Hi, I'm Mr. Ganesha, your AIGUID with the title Introduction to Perceptron and Backpropagation and Understanding the Foundation of Neural Networks. Let's begin with the most basic unit of a neural network, the perceptron, inspired by biological neurons. Just like a biological neuron receives signals and fires if the input is strong enough, a perceptron takes weighted inputs, applies an activation function, and produces an output. Key idea: a perceptron maps input features to an output using a weight vector and a threshold. 2. Perceptron architecture. Single neuron perceptron. Works for linearly separable problems like ANN, OR. Structure: input layer rightward arrow weight sum rightward arrow activation, step function. Multi-neuron perceptron, MLP. Multiple output neurons in parallel. Helps with multi-class classification. Still limited if no hidden layers are used. 3. Perceptron learning rule. Learning in perceptrons is about adjusting weights to minimize error. Constructing learning rule. Use difference between actual and predicted output. Update weights. W_new equals W_old plus eta times target output times input. Unified learning rule. Generalized version that can apply across single/multiple outputs. Training multi-neuron perceptron. Apply same rule to each output neuron. All neurons are trained independently using their own target value. 4. Complexity and limitations. Computational limits. A single layer perceptron cannot solve XOR. It fails for non-linearly separable data. Linearly separable functions. Functions like and/or are separable by a straight line, or hyperplane. XOR is not linearly separable, hence it motivated more complex architectures. 5. Learning XOR. To solve XOR, we need to add a hidden layer. That's where feed-forward networks come in. 6. Feed-forward networks. Consist of input layer rightward arrow hidden layer, S, rightward arrow output layer. Each layer is fully connected. Activation functions like ReLU, sigmoid are used to introduce nonlinearity. 7. Backpropagation algorithm. Backpropagation is how neural networks learn, by propagating the error back through the network and updating weights. Based on chain rule, calculus. Error at output is calculated. Derivatives are used to distribute this error backward through layers. Backprop in fully connected MLP. Start from output layer, move backward. Update weights layer by layer using gradient descent. Tutorial 1. Implement feed-forward network. Use Python, or TensorFlow/PyTorch. Simple network with one hidden layer. Train on linearly separable data, example N. Tutorial 2. Implement backpropagation. Extend previous network. Train it on XOR data. Show how loss reduces over epochs. Perceptrons were the foundation of neural networks. Their limitations led to the development of multi-layer architectures and backpropagation, which today power deep learning systems. Next, we'll implement these networks and see how even a simple neural network can learn complex functions. Ask any question if you have by below comment.